We're going to pick up today where we left off yesterday with some arithmetic series. So let's look at this first, get straight into some examples. This first example, again, another word problem here, dealing with something you all deal with, most of you will deal with in the near future, student loans. It says if a college student borrowed $5,000 in loans, after graduation, the loan was repaid over a 100-month period, with monthly payments as follows: $75 in the first month, $74.80, and so on, all the way down to $55.20. So how much did the student pay over the life of the loan? So let's think about this for a second. Our first term in the series was going to be 75. Our last term, a sub n, equals 55.20. And this is a 100-month period, which is just over 8 years, so n, number of terms, ends up being 8. We're still using the same formula as we did yesterday, which is s sub n equals n divided by 2, all times a sub 1 plus a sub n. In this case, again, n is at 100, so plugging in now, s sub 100 equals 100 divided by 2, all times 75 plus 55.20. 100 divided by 2 is just 50, so s sub 100 equals 50, all times 55.20 plus 75 is 130 and 20 cents. Multiply that by 50, s sub 100, the sum of all those payments added up is going to be $6,510. So over that 100-month period, again, over those 8 years, you're going to pay $1,500 some in interest. Moving on. Now this is going to be something new. When we're dealing with series, a lot of times it is somewhat time-consuming, lengthy, and it can get messy if you're dealing with big numbers. So there's a much more concise and a better way to represent series. It's called sigma notation. Sigma notation, because the Greek letter sigma, kind of looks like a backwards E here, is used. So this series right here, 2 plus 4 plus 6 plus 8, I guess it's not really a backwards E, it's just a forward E. A funky looking E, I guess we'll call it. But this series can be expressed like this right here. I have the 20 sigma over n equals 1, all to 2n. So this right here will be read in this way right here. The sum of 2n as n increases from 1 to 20. So this right here is the last value of n. Down here at the bottom is the first value. And then this right here is going to be that's going to be the formula for the related sequence. Again, still sigma notation. We're still talking about some series. We're still talking about the sum of different things. So let's look to an example and get some more explanation here. So you'll be given this. Sometimes you won't even see this. It'll just say this formula right here. Well, you'll see that represents the sigma notation. So that means I am adding. We're still going to use our formula. Again, I've written it up there. You should have it memorized by now. So s sub n equals n divided by 2, all times a sub 1 plus a sub n. We're still going to use this, but now we just have to find a sub 1, a sub n, and n. So let's start with n. To find n, this is how you do it. You're going to take the top number on the sigma, subtract the bottom number, on sigma, and then you're going to add 1 to it. To find a sub 1 now, so that's how you find n. Top number minus the bottom number, add 1. To find a sub 1, I'm going to take the bottom number on the echelon, epsilon, sigma, sorry about that. Bottom number on sigma, and plug it into the formula. So substitute into the formula. So the formula I'm talking about, I'm going to take the bottom number and plug it into this formula right here. Again, back here, this is the related formula, or the formula for the related sequence. So that's how I find a sub 1, and very similar, to find a sub n, I'm going to take the top number on the sigma and substitute in. Again, the formula. So let's take a look at this example now. N. Top number minus the bottom number plus 1. 6 minus 2 plus 1. 6 minus 2 is 4. 4 plus 1 ends up being 5. A sub 1. Take the bottom number and plug it into the formula. So I get 3 times 2 plus 1. Again, the 2 came from right here on bottom. 3 times 2 is 6. 6 plus 1 is 7. Let's find a sub n. Take the top number, plug it in. 3 times 6 plus 1. 3 times 6 is 18. 18 plus 1 is 19. There's the 3 terms that I need. So plugging this all into our formula right here now, S sub n equals n, 5, divided by 2, all times a sub 1, 7, plus 19. 7 plus 19 is 26, so S sub n, in this case, is S sub 5, we found out what n was, equals 5 over 2 times 26. 26 divided by 2 is 13. S sub 5 equals 5 times 13. 5 times 13 ends up being 65. Another example. Same process. Again, given the sigma notation here, so we need to find a couple things. N, start out, and top number minus the bottom number. So 43 minus 10 plus 1. 43 minus 10 is 33. 33 plus 1 is 34. A sub 1. Bottom number, plug it in. So 2 times 10 minus 2. 2 times 10 is 20. Minus 2 is 18. And lastly, a sub n. Top number, plug it in. 2 times 43 minus 2 equals 86 minus 2, or 84. Plug them all into our formula one last time. S sub n equals n divided by 2, all times a sub 1 plus a sub n. So we're looking for, we just found out n was 34. So S sub 34 equals 34 divided by 2, all times a sub 1, 18, plus a sub n, 84. 34 divided by 2 is 17. S sub 34 equals 17. 18 plus 84 is 102. 17 times 102 ends up being 1734. That wraps up today's lessons. Please feel free to email me if you have any questions regarding anything. I should be back on Monday, and we'll start going over all this series of information.